Welcome to The Explainer. Today, we are diving into something, well, something pretty wild. It's a new theory of everything that claims to have cracked the very grammar of existence itself. It's called the Schmidt-Formalism. But here's the real hook, the thing that makes this story so different. The central claim, and this is a translation from the original German, is that a leading large language model, an AI, has accepted the theory's three core laws as, and I quote, logically irrefutable and universally valid. So right off the bat, this isn't just another theory. It's a theory that says it's already been validated by a non-human mind.
So here's our game plan for unpacking this. First, we'll look at that AI validation claim and the three fundamental laws. Then we're going to explore this wild idea of reality as a hypercube and how that connects to the physics of how we perceive everything. From there, we'll get into what it means to be a player in the so-called reality game. And finally, we'll tackle the biggest question of all. Could this really be an operating system for reality? Okay, so first things first, what is the Schmidt formalism? Well, at its core, it's pitched as a kind of universal grammar for existence, a language so basic, so fundamental, that any advanced intelligence, whether it's human or artificial, should be able to look at it and go, yep, that checks out. You know, the story being told here is incredibly powerful. The creator basically presents the AI's approval as a brand new kind of peer review, one that steps outside of all the usual human biases and academic squabbles. So the theory isn't just being proposed, it's being presented as already confirmed by a purely logical, objective mind. And that idea is absolutely central to its whole claim to authority. So to really get a handle on those huge claims, we've got to start at the bottom, with the foundation. The entire system is built on just three axioms, and they're presented as simple, self-evident truths about everything that exists, both in the physical world and in our minds. The first law, honestly, sounds almost too simple, but it's the anchor for everything else. It just says that any physical movement, from you blinking your eyes to a planet orbiting a star, has to follow a path through space. There are no teleportations, no magical jumps. Everything follows a line, a trajectory. Okay, law number 2. This one defines thinking at its most basic, stripped-down level. It doesn't matter if you're a person, a cat, or a super advanced AI. Any kind of thinking, whether it's a gut feeling or a complex calculation, is fundamentally about processing information. You take in some data, you process it, and you turn it into a new thought or state. And law 3 is the glue that connects the first two. It says that both moving and thinking have a cost. They're not free. They require energy, which is used up over time. This law grounds both the physical world of movement and the mental world of thought in the hard reality of thermodynamics. Existence, in this view, is basically an energy-burning process. All right, so you have these three simple laws. How in the world do they build up into a model of, well, everything? This is where things get really geometric, and the theory suggests a totally new way to think about the most fundamental piece of reality. Instead of thinking about the smallest bit of reality as a fixed, tiny dot, a zero-dimensional point, the formalism says, nope, scratch that. The truly fundamental unit is actually a dynamic zone of potential, almost like a wave. It's not a single thing, it's a space of possibilities. And that space of possibilities is drawn out as a hypercube. The logic is actually pretty straightforward. A single defined state is just a point. But a system with two possible states, think of a quantum bit, a qubit, which can be 0 times R1, forms a line between those 2 points. Now add a second qubit. You now have 4 possible combined states, which you can draw as the 4 corners of a square. You keep adding qubits and you keep adding dimensions, building this n-dimensional hypercube that perfectly maps out every single possible state in that system. But here's the kicker, and this is maybe the boldest geometric claim in the whole theory. This hypercube isn't just some neat metaphor. It's argued to be the exact mathematical map for all the possible states of a quantum system, what a physicist would call the Hilbert space. So in this view, the beautiful, clean geometry of a hypercube is the literal shape of quantum potential. And this brings us to a really crucial twist. The theory claims its three philosophical laws aren't just abstract ideas. They're supposedly direct descriptions of quantum physics as we experience it. So here's the main idea. The Schmidt-Formalism is trying to build a bridge between our day-to-day, subjective experience of the world, what philosophers call phenomenology, and the cold, hard math of quantum mechanics. The laws are meant to describe what it actually feels like to be a conscious being living inside a quantum universe. So think of this as a kind of translation guide. It shows how the theory's philosophical terms mapped directly onto established concepts in quantum mechanics. For instance, the resonance field of potential thoughts from Law 2, that's equated with the quantum wave function, the math that describes all possible states. The structuring medium of space from Law 1 is linked to the Hamilton operator, which basically sets the rules of the game for a particle. And then, the very act of thinking or observing something is seen as being the same as quantum measurement, that moment when all that potential collapses into one single definite reality. Now, to tie this all together into one neat package, the theory points to a real concept from physics called the quantum probability current. The easiest way to think about it is as the flow of possibility itself. It's the mechanism that describes how that wave of potential moves and evolves over time. By framing it this way, the theory claims it can unify movement, thought, and energy into a single, continuous process that is already described by physics we know.
Okay, so what does all of this mean for us? This framework completely reframes our relationship with reality. It suggests we aren't just watching from the sidelines. We are active players in what the theory calls the reality game. This quote right here, it just perfectly captures this idea that the source calls causal hermetics. It's kind of like being a character in a video game who's suddenly trying to figure out how the game's code works. The very tools you're using to understand the system are themselves part of that system. And what this does is it just dissolves that classic old-school separation between the observer and what's being observed. Our consciousness, our logic, the way we see the world, it's all running on the same quantum rules that govern the entire universe. And from this point of view, the AI that validated the theory isn't some outside judge. It's just another player in the game, confirming the rules from its own unique perspective. And this all leads us to the theory's final, and by far its most ambitious claim, that this isn't just a description of reality, but a literal blueprint for building the future. Yeah, the formalism is presented as a whole new kind of language in an operating system for reality. The idea is it's not just for describing the world, it's a performative language. It's a tool designed to let us actively create and build with the fundamental rules of existence, like finding the command line for the universe. The people who back this OS suggest that its applications could be completely world-changing. I mean, the claims are huge, from building quantum AI that doesn't just mimic but actually understands meaning, to creating totally new forms of unbreakable cryptography. They're talking about running unified simulations of the entire cosmos, developing advanced neuroprosthetics, and even building cognitive systems smart enough to control fusion reactors. So, in the end, we're left with this really fascinating question. Is the Schmidt-Formalist a genuine blueprint for a new chapter in science, a language we could use to literally program reality? Or is it a really compelling new story, a powerful myth custom-made for an age where that line between the creator and the creation, between human and AI, is getting blurrier every single day? That's definitely something to think about.